All right, so today we are going to talk about Leetcode question 53, maximum subarray. The question said, given an integer array news, find the continuous subarray containing at least one number, which has the largest sum and return its sum. A subarray is a continuous part of an array. So what it means, this part is like from this given array, -2, -3 is not continuous. So the subarray that is forwarded by -2, -3 will not be subarray. So instead, like -2 and 1, since they're continuous, so this is is a subarray. So for the first example, we have for -1 to 1, this subarray gives as the largest sum, which is 6. And this one is 1 because it only has one number. And this one will be the sum of the all integers, I believe, yeah. So how we are going to solve this problem, let me give you an example. Copy this one. So we actually need two variables called current sum and maximum sum so we need two variables to store the current sum and maximum sum for every single step when we traverse to the array. And one thing that we need to keep in mind is when we add in the number as we are going forward, the current sum might be less than the current integer. So if that is the case, we need to update our current sum to the value of the current integer. So that means like our starting point has to store with the largest number when we compare with the current sum. So let me show you how it looks like. So the first one will be -2, index 0 for the current sum, same thing for the -2. Then we have -2 plus 1 is -1. Now, since -1 is less than 1, so rather than the current sum will become 1 because we want to make sure when we moving forward, our current sum has to like keep the largest number. So that means like the starting point of the subarray will start from here. So that will be 1. 1 can be a -2 will be 1. Then we have 1 plus -3, we get -2. -2 and 1 is 1. And 1 and 1 is 1. So we have 1 plus 4 is 5. Am I making any mistake? Let me see. So -2 to -2 plus 1 is -1. -1 compared with 1. So we take 1. And then 1 plus -2. Oh, sorry. So 1 plus -3, we get -2. -2 compare -3, we take -2. And -2 compare with 1, we take 1. Then -2 plus 4, we get 2. But 4 is greater than 2. 4 is greater than 2, so we want our subarray start from here. So the current sum will be 4. Then 4 compared with 1, we take 4. And then -1 plus 4, we get 3. 3 compared with 4 is 4. And 2 plus 3 is 5. 5 compared with 4, we take 5. Then 5 plus 1 is 6. 6 compared with 5, we take 6. -5 plus 6, we get 6. No, sorry, -5 plus 6 is 1. So we take 1, 1 compared with -5 is 1. Then here is still 6. And 4 plus 1 is 5. 5 compare 6 is still 6. So we get at the end the maximum sum is 6. Right. So that's this one. So let's see how we are going to write our code. Yeah. So we need current sum. We need to initialize our current sum as the first number in the array, and the maximum sum is also the first number in the array. Then we traverse it for I in range of 1. We need to start with 1 because we already initialized it with index 0. So mirrors. Then current sum will take it with current integers, and the previous sum plus current integer, and the maximum sum will update by take the maximum of our current sum along with the previous maximum sum, and at the end we return maximum sum. So let's run it. It looks good, and let's check another example. -2, it's fine. Let's check this one. Yeah, it's 23. So let's submit it. All right, so it looks good. And let's see the time complexity and space complexity. So we only traverse this array 1 time. And yes, so the type complexity that will be bit of n, and as represents the size of the array. And the space complexity is we only use 2 integers to store the current sum and the maximum sum for each step. So the space complexity is bit of 1. It's roughly bit of 1, yeah. So yeah, so that's this question. Thank you so much for watching.